Hey everyone, Tossy here, here at the Fort Worth District event, here with 9418 Pastabots, finalists at the Belton District event. You guys had to check out this robot with the really cool differential arm, able to rotate in so many degrees. It's really cool. I'm excited to get down here on Behind the Bumpers. All right, Amit, let's talk about this really cool robot that you guys, starting with your drive base. Tell me more about it, and then we'll start forward up.
Okay, starting with the drive base, we have the Rev Max Swerve. We swapped the Neos for the Vortexes for the output power. So we have just 4 on the corners. Moving up, we have the Climber here. It deploys down and sandwiches the cage in between these two 1x1s using this alignment plate. And then once it's inside these two tubes, it goes up, brings the cage towards the middle of the robot and lifts it up.
And then let's also talk about this this sort of pivot you guys have on your elevator. Explain that to us.
Yeah, so this is a cantilever arm. We have a max tube here, and it's run by chains on the other side, and it's powered by a Vortex.
Are you able to see this arm in motion?
Yeah, we can show it. So we have a few different positions. We can get both the coil station and ground intake. So we have all 3 levels. Yeah, and we have algae mode, which that's for the net. Yeah.
Now let's hand it over to Nicholas to talk about your elevator, and then from there, just this amazing differential intake you guys have.
So starting with the elevator, we have it powered by chains at the back here. It's running on 2 Neo Vortexes, and then we have it strung to lift the carriage up, 2 constant force springs. And then this is where the magic happens. We have our differential wrist here. It's powered by these 2 Neos here, and it's powered by these belts. You have some tensioners on there with bearings in here. And this differential wrist allows us to get some complex motion with our intake. We really want to be able to do everything with coral and algae with this one mechanism. So this allows us to ground intake that coral, human player intake that coral, and then also score it on the opposite side. We want to reduce cycle times by doing that. And it also enables us to intake the algae in this orientation of the wheels so that we aren't hitting the reef, and then also reach all the way up towards that net and score it.
What was the design process of just creating this beautiful machine that you guys have?
So when the season initially was launched, we wanted to look into some different mechanisms that would allow us to get this complex motion and really package it down into a small profile. Originally, we were looking at having 2 different pivots, but then we decided that the differential would be more optimal for it. So we developed it in CAD early on, 3D printed it, made some minor modifications, and then let the programming get their hands on it so that they could really start figuring out this challenge, and that we had time to develop it and have it ready to go by our first competition.
Can we see some game pieces interact with this?
Certainly. With our intake, we also decided that we wanted to intake coral by the ends so that alignment with the reef could be quite easy, and we could just outtake those compliant wheels, and we wouldn't have to coordinate arm motion with it.
Now, this arm would not work without a lot of programming. Anush, talk to us about this, all the programming that has gone into this robot. It seems to be a lot, so talk to us more about it.
Okay, so starting off with the programming for the arm, we use a high density of PID, feed forward, and motion profiling. We decided to go with the Rev PID that's built into the SparkMax PID controller itself. It allows us to achieve such great motion with this, controlling our velocity and acceleration. This allows us to achieve a trapezoidal motion, which is ideal for an arm like this with such high density weight up here. As for the differential, we use 2 equations. As you can see, we have 2 encoders running here. There's one back here for the roll we use, and then there's one up here for the pitch. If we're able to isolate these 2 movements, and this allows us to basically have both movements happening simultaneously and make our jobs easier as programming and efficient.
And you also have a bit of vision going on. I see a few cameras over here. Talk to us about that vision system.
So this year we implemented a custom vision solution. This is an Orange Pi 5 Pro, and we've done some photon vision scanning on this, and we've flashed this with the latest version of photon vision. This will allow us to do game piece detection and also localize ourselves with the field. These are the two cameras right here. We're using Arducam's OV9281s, two of them, and they're calibrated so that they will be looking for APO tags around the field. This allows us to basically localize ourselves and control our odometry on the swerve. Our swerve odometry tends to get off the more you use it throughout the match. So these cameras are just looking for APO tags around the field, and it allows us to localize ourselves and be accurate in autos. Another use for them is our scoring side is on the climber side. We use these to align to the reef. So this camera placement was pretty critical, as when you are aligning to both poles, your robot tends to shift left or right. So this basically guarantees that we're seeing a tag always, and it keeps updating our swerve odometry as well, making our cycles more accurate and efficient.
Nicholas, I want to ask you a quick question about your team overall. This is your second year for the team. You guys are doing amazing. Finalists again at Belton. So talk to us about your team overall. How has it grown? What's the process it's been for the past 2 seasons? Talk to us about your team real quick.
So we spent a lot of time during the off season honing our skills. We actually did a build with an elevator. That was our first elevator build, so it really did prepare us to come into the REEFSCAPE season and perform well. We did an elevator that was quite similar to this. We built a robot. Its name was Vesuvius, and it picked up 5-gallon buckets. And we were able to transfer those skills quite effectively. We also had some other projects such as an FTC mini swerve, and also in the fall we had our underclassmen working on some FTC projects so that our team is able to be sustained throughout the years as some of our seniors graduate, and we keep that knowledge in the team.
Now, what advice would you give to fellow rookie teams or second year teams that are just starting up and want to be as great as y'all?
So I mentioned this last year in our Behind the Bumpers, but take time on your designs. You don't want to come out with a robot design that you don't want to stick with throughout the entire season. So we did end up spending quite a lot more time on this design, finalizing it, and then moving into that build process.
Well, 9418 Pastabots, you guys are doing amazing here at Fort Worth. Again, finalists at Belton. I'm excited to see you guys make it to hopefully finals again at this competition. Good luck to you guys, and congratulations on your great success so far.